Space telescopes are powerful observational instruments placed beyond Earth's atmosphere to capture clearer images of celestial objects. Unlike ground-based telescopes, they are free from atmospheric distortion, allowing them to observe space in various wavelengths, including visible light, infrared, ultraviolet, and X-rays. Below is a detailed explanation of how space telescopes work. Space telescopes operate on the same fundamental principles as ground-based telescopes. They collect and focus light from distant objects using mirrors or lenses. However, their placement in space gives them significant advantages, such as avoiding atmospheric interference and light pollution. No atmospheric distortion. Earth's atmosphere distorts and absorbs certain wavelengths of light. Wider electromagnetic spectrum observation can detect ultraviolet, X-ray, and infrared light, which are blocked by Earth's atmosphere. Clearer and sharper images, no blurring caused by atmospheric turbulence. A space telescope consists of several essential components that allow it to function effectively. The primary mirror collects light from celestial objects. It directs light to a secondary mirror or instruments for analysis. Example, Hubble Space Telescope, HST, has a 2.4-meter primary mirror. Some telescopes have a secondary mirror that further focuses light. It redirects light to scientific instruments. Cameras capture images in different wavelengths. Spectrometers analyze the composition and movement of celestial objects. Photometers measure the intensity of light. Convert light into electronic signals. Example, charge-coupled devices, CCDs, are commonly used in modern telescopes. Converts raw data into images and spectra. Uses onboard computers and software to correct distortions and enhance images. Solar panels provide power to instruments and computers. Batteries store energy for when the telescope is in the shadow of Earth or other celestial bodies. Sends data back to Earth via radio waves. Receives commands from mission control. Protects the telescope from extreme temperatures in space. Uses insulation, radiators, and heaters. The operation of a space telescope follows a sequence of steps. Scientists choose a target, for example, a galaxy, exoplanet, or nebula. Commands are sent from Earth to adjust the telescope's orientation. The telescope's mirror collects light from the target. The secondary mirror, if present, refocuses the light toward instruments. Cameras and spectrometers record images and analyze the light. Different wavelengths provide various details about celestial objects. The telescope converts the data into digital signals. Data is sent to ground stations on Earth via radio waves. Scientists process the data to remove distortions. Images are enhanced and analyzed to study cosmic phenomena. Space telescopes are classified based on the wavelength of light they observe. Observe visible light. Example, Hubble Space Telescope, or HST. Detect heat radiation from cold celestial objects. Example, James Webb Space Telescope, or JWST. Observe high-energy ultraviolet light. Example, GALEX, the Galaxy Evolution Explorer. Detect X-rays from high-energy sources like black holes. Example, Chandra X-ray Observatory. Capture radio waves from distant galaxies and pulsars. Example, SPECTRE-R, the Russian Space Radio Telescope. Several space telescopes have revolutionized our understanding of the universe. Despite their advantages, space telescopes face several challenges. Designing, launching, and maintaining space telescopes is expensive. For example, the James Webb Space Telescope cost approximately $10 billion. Repairs require space missions, which are costly and risky. Take Hubble, for instance. It had multiple servicing missions. Space telescopes eventually run out of fuel or suffer from instrument failures. Micrometeoroids and space radiation can damage sensitive instruments. Future telescopes will push the boundaries of astronomical observation. These telescopes will improve our understanding of exoplanets, dark matter, and the origins of the universe. Space telescopes are essential tools for astronomy, providing detailed views of the cosmos beyond Earth's atmospheric interference. With continued advancements, they will help answer fundamental questions about the universe, from the formation of galaxies to the possibility of extraterrestrial life.